Greetings and welcome, friends. Today we're going to talk a little bit more about dividing radical expressions. We mentioned it briefly in our previous lesson. But first, a little terminology. Whenever you hear the phrase rationalize a denominator, or like they might use that as directions, I mean, really, in terms of this stuff, I could also just say simplify, because mathematicians don't allow radicals in a denominator. But if you ever see this phrase, what it means is it's the process, right, of eliminating radicals from a denominator or fractions from a radicand, all right? Because if a fraction's inside of a radical sign, then that denominator technically is radicalized, so to speak. So that's the first thing. But today we're going to talk about very particular fractions with radicals in the denominator, where the problems get a little tricky on us. So let's paste this little example.
Oh my lordy.
I guess I'll call this an example here, is what we'll do.
I don't want to see this.
So consider the following fraction: 2 over 1 plus the square root of 3, or all over 1 plus the square root of 3, or 2 over the sum of 1 and the square root of 3, right? So basically the square root of 3 is also in the denominator. So if I wanted to do this, now we're going to actually try this a handful of ways until we discover how to get rid of that radical. But just spitballing, what do you think we could try to get rid of this radical?
You could.
Yeah, that's usually what most people would try. So don't write this down yet, and this is actually exactly the first guess that I would have expected us to try. This is the most educated guess, perhaps, right? So so we'd multiply by this over this, right? And I'd do like this and like this and like this, right? And I would get 2 square roots of 3 over, what's the square root of 3 times 1? Square root of 3 plus the square root of 3 times the square root of 3 is the square root of 3 squared, which becomes 3, or just the square root of 9, which becomes 3. And you're like, yeah, I got rid of this radical. It became a 3. And then, oh no, this other square root showed up.
Won't those cancel out because they're talking about.
Oh, that'd actually be super illegal to do that.
Why?
We'll talk about that kind of canceling later.
Wait,
It could
why-
cancel if this was multiply, then that could cancel out.
Why is there one still down there?
Because I had to distribute this to both of those terms.
Oh.
So it was kind of like playing whack-a-mole, where I just got rid of this square root of 3, the square root, but then like suddenly another one popped up. Yeah, so that technique doesn't work. Other thoughts, ideas?
Multiply it by 2.
Well, that would just be like 4 over 2 plus 2 square roots of 3. It'd still have a radical in it, so that wouldn't be good. Some people think like, oh, what if I just square the whole thing, you know, top and bottom? But actually, that would be illegal, because notice this is an equation. I'm not like squaring both sides of an equal sign. That would be allowed. But just squaring like some number, that's going to change its value, right? Like if I just square 2, that's 4. It's no longer 2, so I can't just do that. And actually, oddly enough, even if I was to square this, squaring this denominator actually does not get rid of the radical. What? Craziness, right? Because I can't distribute an exponent over addition. And actually, just to point that out, some people might try something like, well, what if I multiply by 1 plus the square root of 3 over 1 plus the square root of 3? Don't write this down yet. So this would be 2 plus 2 square roots of 3 up top, because I distribute it, right? Ba-bam. And this,
We cancel.
no,
What do you mean no?
You have to distribute.
2.
I'd have to distribute both of those, yeah.
You end up with 2.
So 1 times 1 is 1, plus 1 times the square root of 3 is 1 square root of 3, plus square root of 3 times 1 is another square root of 3, and then root 3. Yeah, so I'd end up with 2 square roots of 3 plus 3 is what I'd end up having. And I'd have another radical show up. What?
Did you cancel those because they're both adding?
No. Unless this was all multiplying, you can't do that. This and this we could cancel, but that wouldn't actually have been helpful, because it would have still been the same thing. So so what do we do is the question. Darn it. Yeah, I usually I'm a little bit. I usually don't go that far ahead when I have to. Bam! Look, now it's like nothing happened. So it turns out What this is going to relate to, Colton, is a pattern you might remember. A plus B times A minus B. Do you guys know the name of this pattern?
It's the A plus.
Sum and difference pattern. And that's equal to the difference of squares, or A squared minus B squared.
Yeah.
And notice the super cool thing about this side of the pattern. Every individual term is squared. And wouldn't that help us in getting rid of a square root? It would. It would. So it turns out what I'm going to multiply by is not 1 plus the square root of 3.
1 minus the square root of 3.
Correct. I have to multiply by its, do you guys remember the word?
Reciprocal.
These are called conjugates.
Oh,
So this is, so we can write down what's in yellow now.
Oh, yeah. Yeah, yeah.
There's hot.
All right. So these are
Those
called,
probably really small amounts. I regret.
you regret it.
Look at it.
well, you can always rewrite it.
And
So up top, 2 times this. Remember, this vinculum is a type of grouping symbol, so I technically have to multiply by the entire numerator. So that would be 2 minus 2 square roots of thrace up top. And I'm okay with radicals in the numerator. We just don't like them in the denominator.
Where'd you get 2 squared?
because the
Distribute,
one
distribute.
there and
Oh, you.
All right, and for the denominator, or as I like to call it, the debottominator, we could FOIL this or double distribute, or you might have realized, wait a minute, this down here doesn't be a pattern. I'm going to use this pattern to figure this out. So a squared would be the 1 squared minus root 3 squared, because that's the b squared. So this would be 2 minus 2 square roots of 3 over 1 squared is 1, and root 3 squared is 3. Bless you. So this is 2 minus 2 square roots of 3 all over 1 minus 3 is, better yet, negative 2. Well, maybe not better,
so
but
1 minus 3 is 2.
1 minus 3 is negative 2. Because it's, right, yeah. And then in this case,
Can I cancel that?
Look at hard man stealing some love.
yeah, you could cancel the 2's, but you actually have to cancel each term in the numerator by 2 if you were to do that.
Like,
Or
how do I get rid of the negative, like the minus 2 of time?
you can't just do one of them. You'd have to reduce both of them by 2. Let me write it this way to verify that further.
What is cancer?
Let's say I break this and this up into 2 separate fractions over the same denominator.
Do you have to, or can you just leave it?
It's not fully simplified until we do, so we got to.
Find my name.
So 2 over negative 2 is negative 1. 2 over 2, those cancel out. That's going to be the square root of 3, and the minus signs cancel out. So it's the square root of 3. So canceling the 2's out of it, whichever way you end up doing that, is fine, as long as each term in the numerator is eventually reduced by that negative 2. And this would be our simplified answer. And notice, what's wonderful about this, there's no radical in the debottominator.
Where'd you get negative 1?
2 over negative 2 is negative 1. Right, right? Right, right. Right, right. So,
Wait.
I don't mind. So, let's do an example. Example.
Look, it says
Here we
OMG.
go. So I threw 2 sets of directions here just to get us familiar with what I mean by rationalize. Oh, that doesn't work. Oh, darn. Oh, man. No, I can't do that. Here, how about this?
Whoa, is that a division sign?
No, I'm just bam. That's close enough. So, just give my space some room
Okay.
here. So if I said simplify or rationalize the denominator, your goal is the same thing. Okay, you got to get those radicals out of the denominator. So I can't multiply by root 2 over root 2, or root 5 over root 5, or root 5 minus root 2 over root 5 minus root 2. I have to multiply by what? The conjugate.
Say.
All right, so mult by conjugate. So what's the conjugate of the denominator?
5, 9.
Root 5 plus root 2. Remember, conjugates aren't quite opposites, aren't quite the same. The thing in the middle is different. That almost was going to be a song. Yeah. Yeah, it's something like that.
I'm still getting it. I'm giving up just one direction, so I'm just like,
So up top, I'm going to have to foil those bad boys there, don't I? Because those both have vinculums. Root 3 times root 5 is root 15. Root 3 times root 2 is root 10. No? 6? What's up? What?
what exactly does the conjugate mean?
You mean the opposite of the bottom? Or
The middle
opposite
sign
of-
changed is all it is. So it's almost the same. It's just the middle sign is different. So these are conjugates. Right.
Oh, you
Yep.
showed that already. Sorry.
No problem. So let's see. Let's multiply 2 by both of those. So that's plus 2 rads 5. And 2 times root 2 is 2 roots of 2. 2, 2, 2. Cuckoo, ka-choo. So in the denominator, I'm multiplying conjugates. I can use the pattern. So that's going to be a squared minus b squared. It's always a minus sign, by the way. Todo de los tiempos.
Am I even
Because I'm using the pattern. Pattern. Right. A squared minus b squared. So let's see. In the bottom, root 5 squared is 5. Minus root 2 squared is 2. My numerator, are there any things I can simplify? Root square root of 15 has no perfect squares that go into it. Neither does 6 or 5 or 2. And those aren't like radicals. So the numerator I'm just going to leave as n for now. And then I'll come back to it once I combine these.
What do you mean?
And for numerator, I don't feel like writing down 4 terms all over again, just while I'm doing a simplify step in the denominator. And that becomes 3, and that's not going to reduce with anything in the numerator. So that's going to be the square root of 15 plus the square root of 6 plus 2 square roots of 5 plus 2 square roots of 2 all over 3. All over. Nobody knows.
It's all for the cat from that like movie, Oliver and Company, where they're like, well, grandpa and the cat, and the cat's like, with all these people, like, with these, like,
No,
bullets
Emily's
and all
kind of
that
stuff.
There is Oliver Twist.
Yeah. Saw it.
Could I have some more? So, tell you what, here's one more example for you, Oliver, and then we'll call it a video.
I don't want to name my kid Oliver in 10 years when I can have kids.
But spell it this way.
Are you trying to say would be a forever?
So anyways, friends, what do I multiply this by in order to get rid of the radical in the denominator?
5 root 2 minus 3.
All right, friendly friends, follow along. Let's not go distracting our internet friends now, right? They're trying to learn this video here. So I multiply by the conjugate. Equals. Save it for your cheesecake Facebook, YouTube, Twitter account, status. Right, but she can use her own cheesecake channel that she could broadcast her cheesecake eating. So up top, distribute 25 roots of 2 minus 15. Down bottom, don't distribute, save your time, use a pattern. 5 roots of 2,
All squared.
all squared, I like it, minus 3 squared. So, numerator I can't do much with. I'm just going to leave that for now. I'm just going to call it n. How do I square this? You actually have to distribute it.
5 and then 2 by 2.
Will you
When you multiply.
exponentiate?
10 roots of 4.
Nope.
No, it's
5
just-
squared
it's just
Oh,
that.
25
is
roots
25,
of
and root
4.
2 squared is
50.
2, or the square root of 4, yeah. Minus 3 squared is 9. So this is going to be my numerator. That's going to be 50 minus 9, or
41.
yeah. So it'll be final answer. It's going to be 25 square root of 2 minus 15,
Over 50 minus 9.
which is
41.
41. And I don't believe 25 or 15 or 41 have a common factor that I can reduce those by. So that would be it. So the idea for today's lesson, all right, if you've got specifically a binomial in a denominator that has a square root in it, you can get rid of that square root by multiplying by the conjugate and leveraging the forces of this pattern to our will, is essentially what we're doing. So thanks for watching, internet friends. Go on over to my friend Colton's Cheesecake channel. Give her some subscribes. She's going to be posting all of her cheesecake eating and videos, her reviews of Cheesecake Factory. It'll be great. Yeah, well, don't spoil her videos just yet, Emily.
Oh my gosh, Cheesecake Factory.
Wow. Well, thanks for watching. Bye-bye.